All right, so Module 20 builds on some of the things that we learned in Module 19 about functions. Specifically, we're going to look at a different type of data type, or what we call return type for functions, called void. And we'll also discuss the sort of a similar concept with the parameters that we send into a function. So void functions are covered in Chapter 6.4 in your text. And it's really all about whether or not we return data or not. So the initial function from the last module that we wrote was called sum. And we called the function sum. We passed in two parameters. And because the job of the function was to return the sum of all the numbers between x and y, we made it return an integer. Right? The sum of the summation between two integers is an integer itself. Now, that was perfectly fine. However, if we know for a fact that actually the only reason we would ever call this function is because we wanted to print the answer to the screen, we actually can implement this a little bit differently. So one option would be to just call the print function or call the sum function. Maybe we'd call it print sum because its job is to compute the sum and print it. It would compute the entire sum and then print it. And notice that we don't have any return. Right? So if we're going to call print sum and the expectation is not that it gives us the sum, but simply it does a job, it just simply prints out the sum between x and y, then we don't need to specify a return type. There is no return statement. And the return type, you can't just leave it out. You can't just say, well, I'm not going to return anything, so just leave it blank. You need to have some sort of a placeholder, and the void keyword is just that. Void simply says that print sum will do some work. It'll do some C++ statements, but it actually will not return us any data. Right? And that's we're kind of seeing the relationship right here. It would be illegal for us to say return 1 or return s after this statement because we've marked return type as void. Similarly, we can now not call print sum and assign it to a variable. We can't say int sum equals print sum 4, 5. Right? And the reason we can't do that is because print sum now is no longer an expression. It does not actually return data. It just does something. So void is not a data type. Don't think of it as a new data type. It is the absence of data. And we really need it. The only context that we'll use it within an introductory course would be in declaring a function that does not return data. So when declaring a function, you do keep in mind that you must decide on what kind of data you'll return, perhaps none. You cannot choose to sort of sometimes return integers, sometimes return characters, other times return anything. And I'm talking about within the context of one single function. Certainly you can write one function that returns an integer. You can write a different function that returns nothing or returns a character. But the same function can't have an if statement in it and choose, okay, well sometimes under this condition I'll return an int, and under this condition I'll return nothing. In C++, functions must return a well-known and understood type every time that it's called. Other languages actually don't work like that. Something like JavaScript, for instance, is a little bit different in that you can return anything. Makes some of the usage of functions a little bit more difficult, but it does gain some flexibility. In somewhat similar vein, must you have parameters? Do you always need, if we saw the power function has a base and an exponent. The square root function has an input parameter that you're going to calculate the square root for. When we computed the sum, or when we created a print sum function, we have an x and y. That doesn't really mean that your function has to accept parameters. Prime example of this is random. The random function, to do its job, it actually does not require any information to be passed into it. It's not, we wouldn't consider it as a void function. It does actually return an int, right? So there's a return value that's passed back. So the function declaration for random would probably be int random, but then an empty parentheses. Right? But the random number generator has all the information within it that it needs to be able to do the job that it's being asked to do. It contains that random sequence, and it can return it back. So there's no parameters whatsoever. So what I find most students learning this for the first time, and learning C++ for the first time, and have taught hundreds and hundreds of students, probably the point of the biggest confusion is making up your mind in understanding, why is it that I should do one thing in one situation and another thing in another situation. And the thing that I always say is that you must be able to defend your decision to write every line and every character of your program. Every keystroke that you make in your program, you should have a clear understanding as to why you're doing it. And if you don't, you might need to stop and you need to take a few steps back. Within the context of making up your mind of whether or not your function should return variables and take parameters, you need to be able to clearly explain why a function that you write declares the data type that it does, why it accepts the parameters that it does, and why the parameters are the types that they are. And every problem's different. If you write a program that's called print sum, or when you write a function that's called print sum, and you write it such that it's returning an integer, you need to explain why that would be. It doesn't really sound like it should. If its job is to just print, then it's not really returning numbers. It should be void. Likewise, if you write a void function that is supposed to return something, that's not going to make any sense, right? So the answer is not, you don't come to the conclusion of what parameters you write down or what return values or what return types you write down. You don't come to that conclusion by looking at other examples. You don't look at that and say, well, in example 6.8, that there was an int as the return type, so let me put it into my code. That doesn't work. What you need to really think about is, why am I writing this function? Is its job to return an int? Is its job to return a double, a character? Is its job to do just some work and not return anything? That's going to give you your return type. What does my function need in order to do its job? If my function's called power and it's going to compute the base and base raised to the exponent, it needs to know the base and the exponent. Those have to be parameters, because there's no way your function can do its job without it. If I'm writing the random function, I'm not going to accept any parameters because I don't need any additional information that I don't already have within my code. So the simple tip, it goes for these functions, but it goes for pretty much anything that you learn when you're programming. Or at any juncture when you're programming, never guess. Every line of code that you write must have a very clear purpose behind it. Don't just kind of copy and paste from what somebody else did or what you did last time. If you don't know why a certain variable is being created, why an if condition is being used, why a function is being used, why a function is being declared, stop. Think about it. Never write code because you saw it in the book. It actually seems really simple, but it actually is a little bit difficult to follow when you're learning. I promise that will pay huge dividends, though. You might have to go a little slower in terms of maybe lines of code per minute, but you will be faster in terms of programs per minute. You will get to the eventual solution faster if you take your time and you write code only that you understand. Okay, so I want to go through an example of using void functions, and this will just be a function that accepts a numeric grade. So I'm going to write a program that asks the user for a numeric double value between 0 and 100. And you might remember this, we've done a similar problem before we looked at functions. This is just sort of breaking this up into two separate functions instead of one. And then we'll write a function that accepts the numeric grade from main. So main will prompt and read the number from the user. Main will call a function that we're going to create that will print out the letter grade. Right? So the function accepts a numeric grade, it prints out a letter grade, it's not going to really return anything. So let's switch over here and let's start by writing main. I will actually create my input. let's actually state the range, and we can do some input validation here. So we'll wrap this in a do while loop. Oops. And we'll say while input is less than 0 or input is greater than 100, keep asking because it's not a good number. And otherwise, I'm going to call a function. I haven't written a function yet, and you'll notice that I do this a lot. I start to use my functions sort of imagining and hoping that they're already written, and then I write them later. That's actually sometimes a very useful mental tip, mental exercise to do. Use your functions before you actually declare them, because knowing exactly how you're going to use them will help you understand, how you're going to declare them. So in this case, I'm just going to say print grade, and I'll pass in the input. Okay. So print grade, it doesn't return anything. I'm not storing anything in a variable. Its job is to simply print the letter grade. And actually, let's just call it letter grade, print letter grade. And in order to print the letter grade, it needs to know what the user typed. Now let's go above and we'll write that code. Void, because it's not returning anything. Print letter grade was what I called it, and it accepts a double. Not really necessary to call it input. Within the context of main, it sort of makes sense. It's input from the user. But really, we just call this grade. Right? This is the numeric grade. Yes, when we call print letter grade input, the value is called input down here, but the value within that variable will get copied into a new variable called grade, and I can use it inside print letter grade. Now this one is just going to be an if statement, a sequence of if statements, and we've done this before, so we'll go a little more quickly. And I'll do cout. And actually, I think we learned earlier that we should probably store the letter grade in a variable. So we'll say letter equals A, and it will print it out at the end. Else if grade greater than 80, letter equals B. Else if grade greater than or equal to 70, letter equals C. Else if grade greater than or equal to 60, letter equals D, capital D. And else letter equals F. So once we get that code, we can print it out. Letter grade is letter. Right? So we will ask the user for input. We'll do our input validation. Once we get the input, we'll call print letter grade. It'll pass input into grade, and then we can use grade here. If I used input here, I'd get a compiler error. Right? I cannot use input because input is part of main. Just because it's named the same doesn't mean and by the way, I can't do something like this. That'll get rid of the compiler error, but that doesn't make it any better because this is a different variable than this, and so it'll be uninitialized. So let's build this. Give it a run. Please enter a grade. 92, I get letter grade is A. 83, letter grade is B. 45, letter grade is F. So I'm seeing clearly that my function's being called correctly. All right, so continuing on, that's a pretty reasonable example of using a void function. If I'm only interested in printing this out, that makes some sense. Programming example 25 is building on 24. It's actually kind of similar to using program example 24. However, I want to add some stuff. I want to use accumulation inside main to calculate a numeric average of all the grades that the user types in. I'm still going to print out the letter grade every time the user types in a number. So now I'm going to start to, I'm going to develop a loop that keeps asking the user to type in numeric grades. And until they actually say, I want to stop, let's say until they want to type in a negative number, I'm going to print out the letter over and over again. But I'm going to use accumulation eventually to calculate the average of all the grades. Now the thing is I want to use the same function to figure out the letter grade, not only for the grades the user types in, but also for the average. And I want the program to clearly differentiate between when it's printing out a single grade and the average. So let's start by simply just modifying program 24 so it uses a loop and it actually reads in a series of numbers instead of just one. Okay, so let's look at what we've got over here. And what I'm going to do is I'm going to say I have my input validation loop, but really I'm interested in values or in reading several values in here. So what I want to do is call the print letter grade as soon as I get input, if it's positive. If input is greater or equal to 0, I'm going to call print letter grade. And then I'm going to continue around the loop while input is less than 0 or it's greater than 100. So certainly in this case, if the user types in, actually I should say, if input is greater or equal to 0 and input is less than or equal to 100. If it's a valid number, I'm going to print the letter grade out. If the user types in -1, so I'm going to put an AND here. I'm going to say input not equal to -1. So I'm going to continue around the loop while it's bad input. Oh, actually, you know what? Now I'm thinking about this. We really can just stop right there. We don't have to worry about the bad input. So now thinking, let's talk this out a little bit. We're going to prompt the user for some grades. We're going to check to see whether it's valid input, whether it's between 0 or between 0 and 100. And we're going to stop the loop now when input is equal to -1. And so let's just run this first. Make sure we have those loops figured out correctly, because botched it a little bit. 82, 45 is an F. If I type in -6, notice I just keep going around a loop. I don't print out a letter grade. If I type in 103, same deal. If I type in -1, I stop. All right, so I've got my loop set up correctly. Now what I want to add to this, and notice, so I'm continuing to call print letter grade over and over again. Now I want to come up with a sum and a count, and I want to do my standard accumulation. Of course, I only want to do that if it's valid input. So sum plus equals input, count plus plus. And after I'm done reading in all the values, I'm going to print out, I'll actually create a variable. I'm going to calculate the average as sum divided by count. And for now, let's just print out the numeric. So let's take a look at that. So if I get a 90, 80, and a 70, my average should be an 80, right? If I get a 96, a 90, and 93, my average should be 93. And if I get something a little bit less calculable, 90, 67, and an 82, right? Looks reasonable. And we could use numeric precision or whatever, but that should be sufficient. Okay, so I've got the letter grade printing out every time the user types out a number. But now I also want to print out what the letter grade of the average is. So first off, notice that I can just recall print letter grade. And instead of passing input in, I'm passing average, because I don't want the letter grade of the input the user just typed. Now I want to print out what the letter grade is for average. Print letter grade didn't ask the user for a number, right? Print letter grade doesn't know where this value came from. It just knows that it's being asked to print the letter grade corresponding to that, excuse me, to that specific parameter, right? So this sort of already works. Type in 90, 67, 82, -1, the letter grade is a C. And again, we don't have C pluses and stuff, so it's pretty harsh C, but okay. Now, so far so good. We have this reusable function that can print out the letter grade, whether it was typed in from the user or whether it's the actual average. It doesn't make a difference. However, we were asked specifically in this example, I want to clearly differentiate a single grade and the average. So what I mean by this is I'd like the program to print out, well, the letter grade for that particular assignment is this, and then at the end, the letter grade for the average is this. So what I'm getting at is that depending on whether it was user input or whether or not it was the average, I want this print statement to appear differently. I want this print statement to say, you know, your average, the letter grade for your average is, or the letter grade is. And that presents a little bit of a problem because print letter grade has no idea, and we just got done saying how print letter grade really doesn't care where a grade came from. It doesn't understand, there's no information inside print letter grade about the context under which it's being called. The context of this call is this is user input. The context of this call is that this is an average. But up here, once we call this function and we enter into this function, there is no context. Now the solution to this problem is not to add context. And what I mean by that, we're not going to add another parameter and say somehow some flag that indicates, okay, we'll print out the word average instead. What we're going to do instead is recognize that while letter grade knows how to create the letter, letter grade knows how to calculate the letter, it doesn't necessarily know how to do the print best. We might print it one way in one situation and another way in another situation. So what's probably better here is to not use a void function. That doesn't mean that we never use void functions, but in this situation, if I want something different to print out, I probably just want print letter grade to be get letter grade, to return the letter grade to me so main can figure out how to print it. Because main knows why it's calling it. Main knows here that print letter grade was being called to print out input. Main knows that print letter grade was being called to print out average here. So I'm going to change this. I'm going to return a character, the letter that I compute. I'm going to return letter instead of simply printing it. So this should really be renamed something, maybe get letter grade. Now in main, I'm going to create a variable to hold this. It could be called letter to match up with this, but it doesn't need to. It could just be called let, whatever you want to call it. And I'll say let equals get letter grade. And now I'll print that value out. So it's sort of just a different way of doing the same exact thing. Letter grade is let. Right? Remember, get letter grade, the fact that it's returning a character letter, you don't need to name it letter. You're just taking this value, you're solving you're getting that expression value and you're assigning it into a variable. It could have been each time we call this, we might save this in a different variable. We're not going to do that here. I'm going to say let equals print letter grade. And now, of course, since I have the, get letter grade, since I have this character, I can print it out any way I want. So maybe say average is average, which is a letter. So now getLetterGrade does its job. It computes the letter. And I decide in main, after calling getLetterGrade, how I want to print it. So now when I type in 90, 67, 82, -1, average is 79, which is a C. So kind of reflecting on this a little bit, I don't want you to get the idea that void functions are never good. However, you try to make your functions do one thing and one thing only. Having print letter grade as a function tends to kind of handcuff you a little bit, because not only are you computing or calculating the letter, but you're also printing it. It's better to actually have functions just do one thing, in terms of this just calculates the actual letter. If I wanted later on to have a function that its job was to print the letter grade, I could have another function. I could have void print letter grade double grade, and actually just say cout letter grade, and then call getLetterGrade. Defer to getLetterGrade, who knows how to compute the letter grade. So there's no rule that functions can't call each other. And now I could actually call print letter grade just like I did before. But down here I would not call it because I want to print it differently. This works exactly the same way. When I call print letter grade, input gets passed into grade. Then print letter grade calls getLetterGrade with grade. That grade gets passed into this grade. A letter is calculated, returned. This expression's evaluated. It's a character. It gets printed out. If I run it, the results are indistinguishable. Having your functions do one thing and one thing only is a trick that even professional software developers sometimes struggle with, but it will eventually start to save you an enormous amount of effort and time thinking about how to solve your problems. So lessons learned. The original print grade example that I went through, the function did not return the letter grade, it just printed it. That was perfectly fine for that context. In the second example, I started actually using this print letter grade for several different reasons. Depending on the context, the print statement was different, so it made a lot of sense to return the character grade rather than printing it in the function. Right? The code in main knew why we were calling letter grade better than letter grade knew, and so we decided to print it in main. All right, so the lab for this module. This is one of the few times when we start looking at functions for the first time, I'll kind of push you into a specific way of writing your code. But eventually, I want you to be able to decide which functions make the most sense at which time. But I'd like you to build on Lab 7, but include Lab 7 just had you printing out half of this diamond, or the right half of this diamond. I'd like you to now print out the leading spaces so you can print a true diamond. Right? So think about these. This obviously won't show up to the screen, but these spaces really are just printing out the space key. I'd like you to create a function called print characters that accepts two parameters, the character to print and the number of characters to print on a given line. You should call this function on each line twice, one for the number of spaces that you're going to print out, and one for the number of stars that you're going to print out. write a set of for loops to calculate how many spaces and how many lines on each line, or how many stars on each line are going to be used, but use your print characters function to actually do that work.